videos, we are gonna go deep dive into generative adversarial networks. In the previous sections, we are doing generative modeling through BAE and BAEs and so the quality of images which we are obtaining from BAE is not good as which satisfy our needs and so the GANs will help us to generate such a realistic images for us. And the GAN, let's look on to the history of GANs. GANs actually is developed in 2014 by this guy Ian Goodfellow. I think he done this great inventions. I think he's now at OpenAI or he has been working on OpenAI, Google Brain, and other companies, isn't he? And this is the GAN is considered as one of those great inventions of the previous decade, isn't he? Which has revolutionized the capability of computer to generate things. So GANs is just a combination of two neural networks. Is I think he has done fantastic job, isn't he? Uh, Arranging the network in such a way is arranging the component that already exist and just he says this is also a neural network. He has fantastically arrange the network so that it can generate the new data. So let's go on to the what is GANs and what are the current applications of GANs in our daily life. So in our daily life and in the fields and in the current fields. So GANs is a deep learning architecture. It trains two neural networks against each other to generate new data. So new what data that have the similar attributes in the training data. So before the definition this is the general architecture of GANs. This is a network. This is the architecture of GANs. We'll deep dive into the each and every components and how we're going to we'll learn about this component, this random Latin vectors and generate a network and this images and this discriminator network and this is the training data and this is discriminator network and whole training process we will just break down the every component of the GANs and we will go deep dive into it and we will also learn how this or collectively to generate new data so before going to the GANs before going to the architecture and just going to the each and every components and all the maths involved. Let's look at what are the application of the GANs in the in the real world. So GANs, first of all, GANs, as we know, GANs helps to generate human faces as realistic as possible. Look at it, it is generating such authentic data. You can it's undistinguishable data which we deal in the real lives and it is creating such a realistic images and let's look some other applications of those GANs and GANs can be applied as a data augmentation because GAN is learning a probability distributions of the training data of the training data so we can sample the other data we can generate the other data from that distributions of the distribution of the model we'll first of all create those distributions. So we find the distribution of the model and we will generate more samples from that distributions of the training data and we will create more data more data and GANs helps to generate diverse and realistic images that can expand the training data sets and help the model to learn proposed representation. We can learn we can first of all generate more data from the limited data, and we will synthesize more data, and we will we will get the full robust representation of the data, and we can apply that generated data to train our models, and it can help in generalizations, of the model can understand a better representation of the limited training data, and it can help in the problem of limited data, as for the specific task, as where data is pretty less, and it can help us in reinforcement learning, to for the reinforcement learning agent, to create a physical environment is pretty expensive and costly, and so we can generate some synthetic environment, or a synthetic environment, so that the agent can do its things in that environment, and just learn from that environment, and without doing real harm in the physical world, I think we can create a synthetic world or a synthetic environment for the agent to act and to get the response from the environment, and it can learn from that generative environments, so we have to create some environment so it can learn from it. And for multimodal output, we are doing for, as we done on AN and CNN, we are just giving mapping a big input from text to text to one. So it is for sentiment analysis, we are giving the whole text, and mapping to is negative or positive. We are just mapping to the one thing, isn't it? We in sometimes we need multimodal output, isn't it? We need text, image, not only the prediction values, isn't it? For example, in a binary classification, not only binary classification, for general image classification, we give the image to the models, and it gives it gives the output, as zero or one, so we doesn't want that. We need something. In some cases we need multimodal output, not only the text, not only the numbers, and we need such a multimodal output, so GANs can be come in handy while doing this type of tasks, so and generate, this is same character, same as generate cartoon characters or even any characters, so and in video prediction and also in video generation, from the text, GANs can come into pictures, and so it can also predict the frame, first of all, we have given this frame, and it can be trained, to generate the next frame, and this had been just given example. It can be used as predicting the next frame, and also we have given some text, and it can generate the videos what we want. And this is also an interesting application of GANs. So image to image translation, we give the sketch of this of the bag, and it can generate multiple bags, in this bag, and so if you give this, it will generate this bag, and it's pretty easy to make this type of training data, because from we can apply the tools, we can apply the tools and just generate these types of sketches, and just from the real images we can apply some tools like edge edge detector of of the images, and we can find this tool on online, and we can just create the training data for this type of purpose easily, so we can just pass this real, and it will create the sketch, and we can train the model to to predict output given the sketch of those images. And in other domain like drugs discovery and molecular design, GANs can generate novel structure with desired properties, adding in the drug discovery and scientific materials, in material sciences, it can generate molecular structure that have a desired property, and that are specific features, so we can from the existing we can create similar but also novel with having desired properties, For specific purpose, we need a for particular material we need specific properties, and so to find that specific property, we can apply the GANs, and for photo painting, if you have some black spot, we can just apply GANs to fill this images. This cropped images we can use to fill this images. And the another application, as we have already seen, I think what's the aging of the what's the person will look like after 20 years old. So it can learn the data and just try to map it to this if you have if you have the samples, we can train this, and it will able to generate this type of images from given this type of images. This is also image to image translation. So um, and in fashion if we this is also try on, you can see in this type of if you show your face and the glass will just come up into your eyes, and if you just show your bodies, and it will just cloth will just adapt into your bodies, and it is very effective in online shopping and online purchases, and it will help businesses and customer, mainly the customer, to how the clothes suits on me, and how the glass fit on my eyes, and how it's look and generative models can really work on well on this such as from online try on application, like try on this try on this and how it's look so it's fantastic. And just removing this also can photograph editing from this rainy to this to this. And also I have found more application from this machine learning masteries GANs applications. So and just I'll give you some that I like much. And so it can we can do 3D generation. 3D object generation is also the one of the applications. And the clothing and some editing we can apply here. This is a photo in painting. We are trying to fill out the existing one, and we can just convert the low resolution into high resolution, isn't it? Super resolution images. This is the original, isn't it? This is the GAN, isn't it? And this is pretty this technique by cubic is applying manually the mathematical calculations, and this is combining two images and how it's look, isn't it? It's blending each other. This is the blending of this and this. It's the blending, image blending. So yeah, it has fantastic applications, as you can see. So you can just go through it as a photo to emoji, and other application I have also mentioned here, as it must be so in also in game development, doesn't it? It can help to create the environment, doesn't it? Without manually writing content, doesn't it, for those game environments, doesn't it? It can learn to generate some certain environment from the real, if you have given enough training, the GANs can just make those content without manual content. We can create some game textures and characters without writing manually the contents GANs can be really good in game development, and also in other applications of GANs can be seen in. There are also various tags you can just search on it, isn't so? I think this is the few application of GANs, and let's move to the next sections. So in this section, as in, we will just take a brief overview of GANs and not not those any mathematical part, but in this section we'll just go and just understand the basic architecture of GANs. So GANs actually, I will give you the most comprehensive one. So you can just take it. This isn't. So this is a generator. So this is a generator. It's a neural network. This is also a neural network. It consists parameters. It consists parameters, and we have this two network. And this is neural network. And if we are doing, we are creating image generations. We mainly use convolution neural network. So what? And this is the real data. So we have to. This is the real data. Our image data. This is our image, and image data set, and this is the random input, which is probably sampled, which is a normal distribution, a sampled vector from normal distribution or known distributions from our sampling process. Sampling is easy, we sample from this, where the sampling process is easy, and we probably use normal and uniform listening for the sampling of this random vector, and we pass this random vectors into the generator, and it will create a sample, and this is also a sample from a real data set, and we will give to the discriminator, the discriminator is a classifier, just a binary classifier, which function is to, detect this, which to detect this sample, which sample is fake and which sample is real, and it will give two loss, discriminator loss and generator loss, this is also the components, so we'll also, go into the detail of that, so let's look at it, what is it. GANs helps on generation, so uh, we want to generate new data, we have the training data set, which contain images of particular things, first of all, imagine this real data, it contain the image of faces, so from these faces, faces of data, thousands of faces of data, first of all we want to map, we want to map this distribution, we want to map the distribution, and from that distribution we want to generate new data, so first of all we want to find approximate this, the training data distribution, how the, training distribution look like, and we want to just sample from that distribute that same model distributions, we can to sample it, so uh, so we have to train, this is our only the trainable, component here, this and this loss also, so this is sampling, we doesn't need it, so real we does not backup bracket on that, so this has a parameter, this has a parameters, and this is the loss functions, and so uh, the generator, we give a random input and it will generate data, for us, both, both generator and discriminator are neural network. The generator, output is directly connected to the input of the discriminator input, through back propagation, the discriminator classification provide, a signal, that is used to update its void, so, it will classify it, it will classify it, and, it will give feedback, as a signal, and it helps the discriminator to, classify the images. Guys, let's understand the GANs more deeply and just go to the each and every component of GANs. So, we will look at the every component of GANs. So this is generator, this is discriminator, and this is the random input which is sampled from. Gaussian distributions or uniform distributions. Will sample from the distributions which is easy to sample from, as in, so we may mostly sample from Gaussian or uniform distribution. So we will look at it as every component, this random input is generator, sample, discriminator loss, generator loss, and the real training data, and we will train the whole component. So we will gonna go look at every component, the discriminator and the generator losses and random input, and also these paths and how the training path or the gradient, how the gradient is flow through the network. We will look at it is each and every component. So first of all is both the generator and the discriminator are the neural networks, and they both are neural network. The generator output is directly to the discriminator input through back propagation, as in the discriminator classification provide us signals that the generator used to update its weight. So we will give the generator output to the discriminator input, and also the real images from the training data set. So we will give it to the discriminator, and discriminator gives the result, and it classification provide a signal for generator to become more better at generating new data which is similar like the training data set. So the main purpose is we have to train the generator so we can use it later to generate more data or to synthesize more data from it. So if we train this whole network, we will just need this part for our use cases. We can also use this for different purpose, but to generate we can just use this network for generate more data. Both the this can be used as the anomaly detection, because it will tell which is real image, which is fake image. It can be used in some cases like anomaly detection. So discriminator can have also huge component of GAN is first of all discriminator. The discriminator is just a classifier, and it try to distinguish the real data from the data generated by the discriminator. It would use any network architecture according to the data it's classifying, if it's classifying image, we will use the neural network architecture as CNN, and for numerical, purely numerical, since we can use neural network also, so ANN also, and for different purposes we will define the discriminator as a different, and generators learn to create fake data by incorporating feedback from the discriminator, and it learn to make discriminator classify its output as a real, as in real. So generator just just learn from the feedback given by the discriminator and try to become more better, from the feedback given by the discriminator neural network. The generator neural network become more and more good at more at generating, not a classifying, for generating new data. So, and this is the input latent vector, as a random input vector or latent space. We have to sample from the latent space. So this is the random input vectors. This is just a set of numbers. We can take a 100 dimensional numbers and a 100 dimensional set of numbers, and we can just pass to the generator. We can just pass to the generator, and it will generate new data. So it is a most probability sample from normal or uniform distribution, as I have already said. So the main purpose of this input random vector, when it go to the generator, the generator waits and the input the latent vectors align in such a way that they can generate the data which looks similar as the training data. So when this 100-dimensional latent vectors, or you can take any dimensions for the clarification. For now, I will take 100-dimensional and I will pass it through generator network, and it will the generator weights adapt. We have to learn the generator weights, so that if we example from a particular distribution, like from those Gaussians, or from Gaussian distribution, when you give that to the generator, and generator weights are at a good direction, or generator every words are at a good direction, so the random vectors can be used to generate the data that look like the data present in the training data set. So it can be used as a numbers in which, and we can sample any number of, we can sample the distribution, we can sample the from the distribution, and we can generate multiple images which we have to first of all train the we have to align the weights of the generator in such a way that if we sample the this of 100 dimension, 120 dimension, and just it can just pass through it, and the weights and the random sample from particular distributions align in such they both combine and just generate a new data instances which look resemble the data present in the training data set. And the input random vector, it can be dimension of 120 and other dimension also, and this is the gradient path. Gradient path is just how the the error, and how the backpropagation, what's the path of a backpropagation what's the path of gradients, how the gradients from the error functions, and how the gradients flow entire networks we'll just look at how the gradient path is, in more details, but just for understanding this is the gradient path. This is the gradient path, as in how it's come here and here, and this is the gradient path which will give a feedbacks into the discriminator and generators. This is not a perfect architecture, but you can use it. This is the gradient path, as in this is the gradient path, how the gradients propagate through this and this, and this is a latent random vector, and this is the real data sample and generator and discriminator. So you have, I think you have just get the brief understanding of the GANs, how it's work, and just I want you to visualize the network in your brain, as in so this is simple, as in you can visualize. And let's go to the loss function, as in we have a two loss functions, as in for a discriminator loss and generator loss. We have the loss function, discriminator loss and generator loss, and I will show you in this article, isn't. From this article I will using it, isn't it? So discriminator loss is this is a loss function, isn't it? This can be let's just look at it, and we'll go deeper on it, isn't it, as we move on, isn't it? But for now, isn't it, what is the loss function? I will just explain you, isn't it, what is written here, isn't it? While the discriminator is trained, it classify both real and fake data from the generator, isn't it? We have to train the discriminator. It's classify both real and fake data from the generator, and listening. It penalizes itself. It penalizes itself for misclassifying a real instance as a fake and a fake instance as a real fake instance as a real, listening, by maximizing the field function, listening. This function actually what does is penalizes itself for misclassifications, and the term will go into that how this work, but for just learn this some terminology for using log of dfx refer to the probability that the generator is rightly classifying the real images, and this minimizing this would help it correctly label the fake image that comes from the generator. This is generator loss. We'll go on deeper on that. So just understand this thing is this is a generator loss and it's a discriminator loss. And at first time it is not easy to grasp. We will just break down it and we'll derive it from the basics. So don't be worried for it. So in the next sections, in the upcoming sections, we will learn it. Just for understand the basic components here. Just visualize it and just visualize the basic components, and let's go on more detail on the. This is just a brief introduction of discriminator, generator, and gradient path. We will go on much more deeper on the each component now. For this, I will take this article from Google Developer. So, and we will just go through it. This article. So, what's this article is just to give you the little bit of understanding of listening. First of all, the we have two networks. GAN has two parts in generator and discriminator. Generator learns to generate possible data means convincible data as in convincible data, or generator try to be better at creating the most convincible data in first of all time, and discriminator learn to distinguish the generator generated fake data from the real data. Discriminator penalizes the generator for producing impeachable data or not a realistic data so at the first listening just understand this is a I will just want to you uh, the different way of teaching you listening. So first of all listening, just understand the discriminator just is the classifier listening which will at the first time it will classify the generated data and the real data. It can at the first time listen it is very good at listening classifying it listening real and fake as the generator listening goes well listening, and the training continues and generators the feedback given by the discriminators in discriminant network is in the generator try to be built from this to this and this to this and generator really try to map those in a real data distribution. It's able to map the real data distribution and it's now able to generate such data that is really look like the real data. And the discriminator is does not classify doesn't can't able to classify the real and fake, and this is the generators become better. And here the whole picture of whole system, this is the whole system. Both the generator scheme are neural networks. Yes, let's look at the each component what I have already in much more detail and depth. So the discriminator is this network so first of all to we do backpropagation. We first of all train the discriminators, and discriminator has a different we have a two training. We have only discriminator training. First of all we train the discriminator to classify the fake and real listening by giving the real sample and a fake sample. We train the discriminator model, and discriminator model is capable of distinguishing the real and fake images. And this is the training loop of discriminator. So first of all look at it as in what's written here. Just I will read out for you. It's a simply classifier. The discriminator is just a classifier which classify the real image from real image and the fake generated fake samples. So it's just a classifier which distinguish the real and fake data. And this is the how the backpropagation and discriminator training happens just from this part only. We are not training in case of discriminator we just train this part listening. So just generator take the input and just find some loss and some create some loss, and we try to reduce the loss by backpropagating and changing the weight of discriminator, and it is become capable of distinguishing real and fake images. And for discriminator training data for the discriminator training we use real data from our dataset and fake data generated by the generators. The discriminator uses this instant as a real data as a positive instances and negative data as a false instances. So the data for training a discriminator comes from two sources: the real data from the training data set and the fake data from the generator's generated data. Yes, training the discriminator is discriminator connect two loss functions. The during discriminator training, the discriminator ignore the generator loss and just use the discriminator loss. While training the discriminator, we just focus on discriminator loss and we forget the generator loss. We use the generator loss during generator training is as described in the next section. So and just look at it during the generator discriminator training. What we do is actually listening. Discriminator both classify real and fake data as fake data. The discriminator loss penalizes the discriminator for misclassifying the real instance as a fake and fake as a real instance. So just want to learn the discriminator loss is just penalizing if it doing misclassification and updating the word doesn't and updating the word through backpropagations through the discriminator network. And this is the discriminator part, and we will also look at it from scratch, even go deeper in the discriminator part. Just develop the understanding right now from this blog just make a little bit of understanding and just try to absorb things as we can so we will go even deeper on this generator and discriminator while doing training part and how what is happening in the discriminator and how all things align. We will go on even deeper on that. First, look at the generator, the second component. We'll go on much more deeper on the generator. What we have the knowledge right now. So, generator part of a GANs learns to create fake data by incorporating feedback from the discriminator, and it learn to classify. It learn to make the classify its output as a realism. So, generator is just a network, it's a neural network which feedback coming from the discriminator. It's the feedback so it learned to become much more capable of generating data that looks similar like a training data set data. So it just incorporate the feedback given by the discriminator and try to become much more better and better. So generator training require tighter interaction between generator and discriminator than the discriminator training requires. So we need to have integrate much more components in it. So while generator training we can't just it's not easy as training for discriminator. So its training is require tighter integration for training the generator. So the portion that include the we will include some much more portions in these are the portion we will include in we will not include this portion because this is stochastic process. We doesn't have to include it, just is sampling processes. So and this is random vectors and we doesn't need we need this process in generator loss and we will backpropagate through it. And during the backpropagation so I will read out it. The random input, the generator network which transform the input data into data instances. The generator network will transform into data instances. This generator network will transform the random into data instances, and the discriminator network which classify the generated data, and the discriminator output. Discriminator output means the output given as the discriminator, and the generator loss which penalizes the generator for failing to fool the discriminator. And we have generator loss which penalizes itself basically for failing to fool the discriminator. Our main purpose is to fool the discriminator, and we'll learn why we have to fool the discriminator even deeper as we go on forward. And that's it. And I have already told on that why this random input part, so I will not repeat it. So using the discriminator to train the generator. Mm, so I will just tell the gist of it. while training the discriminator, we will listening use the signal generated by the discriminator, and we will take that feedback and update the weight accordingly to that. So during the backpropagation, we are just making the changes in the weight of a generator only. We are not training the discriminator weight, and we are just updating the weight of the discriminator. So I will give it use it. So whenever discriminator tells this is a when the this generator this is a fake images, fake images, so it will give some feedbacks and it will give some loss, generator loss, and this loss will be back propagated through the network, and the we have to make the loss as much, generator loss as much as less, isn't it? So generator loss means, isn't it, the discriminators say that it is fake images, so we have to adjust the weight of this passes, and this is the while training the generator, isn't it, we will freeze the all the weights and parameter of the discriminator. So when we give those random input to the generator, and it will create sample, and it go to the discriminator says, generator some discriminator say this is a fake data and there is some generator loss. So and generator loss, this is not a train, discriminator is not trained right now, it's not trained right now. So when when there is certain losses in, we want to back propagate through the network, and we want to make the discriminator to tell this is a real image, isn't it? So for that we have to update the weight of generator in such a way that the discriminator tell us that this is a the generator loss is minimized, or so we try to update the weight of generator only, isn't it, to make the discriminator to tell or minimize the generator loss as low as possible. So in the training process, and we just update the weight of generator, and we does not train the discriminator weight. And we train the generator with the following procedures, and we sample the noise, and we will create the output of generator and do classification and calculate loss for the discriminator classification, back propagate through both and the discriminator and generator to obtain gradients, use the gradient to change only the generator weight, we are not changing the discriminator weight. So this is the one iteration of general training. In the section, in the next section, we'll how to juggle the training of both generator and discriminator. So guys, the training of GANs is not as easy as to train others. And so we have to train this generator and discriminator. We just go through the individual training, but in real training we does not train them as individually, we train them together with, we train them as bit by bit, so we train little bit of discriminator, and we'll train little bit of generator, and we'll go up, and we'll train discriminator little up and generator little up, so we does not train at once, so we'll juggle the training between generator and discriminator. So we'll not train the discriminator at once, and give the classification signal to generator and update the weight. We do not do like this, we'll train step by step, we'll train little bit of discriminator and generate and give the feedback, and do some classification and give the feedback and update the weight of generator, and the generator will try to use the feedback and change the weight of generator and generate a more better sample, and it go to the discriminator, and discriminator give some feedback, and it will become even better, and if the generator becomes sufficiently better, and we will even train the discriminator, and and even as in generators, give much more feedback, and discriminator give classification result, and we and then discriminator become in second training discriminator become much more better, and it will give the certain loss of the better generators. And so we will train them bit by bit, and we will not train them both simultaneously and at once. And we will train first, we will train discriminator and then generator, discriminator and generator, so we will train them simultaneously.